Okay, so here is question 7 of induction, and we want to prove that 1 over 1 squared plus 1 over 2 squared plus 1 over 3 squared and so on is smaller than 2 minus 1 over n for all the n that is larger than or equal to 2. So to proceed by induction, we start from the base case. So when n is equal to 1, the left-hand side would be 1 over 1 squared, which is equal to 1. And the right side would be 1 over 1 over 1, 2 minus 1 over 1, which is 1. So we have shown that this statement is true for n equal to 1. Then we're going to write the inductive hypothesis. So assume 1 over 1 squared plus 1 over 2 squared plus 1 over 3 squared and so on is smaller than 2 minus 1 over n for all n that is larger than or equal to 2. And then I need to prove that this statement is true for n plus 1. So 1 over 1 squared plus 1 over 2 squared plus 1 over 3 squared and plus 1 over n squared and 1 over n plus 1 squared. Okay, and it is smaller than 2 minus 1 over n plus 1 for all n that is larger than or equal to 2. Okay, so now we're going to write the inductive steps. So since we already know that 1 over 1 squared plus 1 over 2 squared plus 1 over 3 squared and so on is smaller than 2 minus 1 over n, so we want to add 1 over n plus 1 squared on both sides. So it would be like plus 1 over n squared. Okay, so now the left hand side is completely same as this part, so now we're going to focus on the right hand side part, and we're going to rewrite it to make they have the same denominator. So it's equal to 2 minus n plus 1 squared over n times n plus 1 squared plus n over n times n plus 1 squared, and we add them together, we get n squared plus 2n plus 1 minus n over 2 times n times n plus 1 squared. We're going to do some calculation here. N squared minus n minus 1 over n times n plus 1 squared. And we want to take this 1 out of this fraction, so it can become like n squared plus n over n times n plus 1 squared minus 1 over n times n plus 1 squared. And rewrite this fraction, we have n times n plus 1 over n times n plus 1 squared. So we can simplify this part and get 2 minus 1 over n plus 1 minus 1 over n times n plus 1 squared. Then we already have 1 over 1 squared plus 1 over 2 squared plus 1 over 3 squared plus 1 over n squared plus 1 plus 1 squared. Since we already proved that this part is completely same as this part, so it's smaller than 2 minus 1 over n plus 1 minus. So we already it's really close to 2 minus n plus 1 over n plus 1, which is what we need from here. So if we can prove this part is smaller than 2 minus 1 over n plus 1, then we can compare those three parts, and then we can get what we want. So now we need to show that this part is true. So we start from n is larger than or equal to 2, which means that n times n plus 1 squared is greater than 0. And also 1 over n times n plus 1 squared is greater than 0. And we change the sign here. We got negative 1 over n times n plus 1 squared is smaller than 0. So we add 2 minus 1 over n plus 1 on both sides. We have so we already proved what we need here. So which means that we already showed that 1 over 1 squared plus 1 over 2 squared plus it's smaller than 1 over n plus 1. Okay, so we already proved the inductive hypothesis, which means that by the induction, the original statement is going to be true. So that's it for the question 7 of induction. Thanks for watching.